So in this video, we're going to talk about significant figures of pH calculations. And how we kind of figure out how many sig figs a number has when we're dealing with this, which is a little bit different from all the other sig fig rules that we have talked about in the past. So let's just kind of jump into it. And so, like for example, if we have a number that has if we have a calculation, right, and we see that the pH is 7.4, all right, now we have to kind of figure out, okay, how many sig figs we have. Well, in most times you look at this, it's like, oh, well, this is 2 digits, most likely it has 2 sig figs. Not really. Okay. Okay, so let's talk about pH and why that is not the case. So pH is a logarithmic calculation, all right, which basically these numbers tells you to like what power is your the concentration of hydronium in this case, right? And so this number here basically tells you to what power of negative 10, really, because remember, pH is equal to the negative log of the concentration of hydrogen ion or hydronium ion, right? And so this first number kind of really just tells you to the what power or to what decimal place, all right? And so the number before the decimal, all right, so the number before the decimal, it's never counted as significant. All right, it's never counted as for significant figures. So when we're looking at a number like this, the numbers that comes after the decimal place, so here's your decimal, the numbers that comes after the decimal place is what's considered significant, okay? So this number is your significant number. So here, when we consider 7.4 as your pH, then we have 1 sig fig. And so if we were to try to determine how many sig figs the concentration of hydronium for the pH of 4, so if you have pH of 7.4, so if you have a pH of 7.4 and we want to know what's the concentration of hydronium, then we know the concentration of hydronium is equal to 10 to the negative pH, all right? And so basically what we'll say is the concentration of hydronium is equal to 10 to the negative 7.4. All right, and so because this number only has one decimal place, all right, our answer is only going to have one significant figure. And so the answer here will be 4 times 10 to the negative 8 molarity. So that will be the concentration of the hydronium ion. Now, we must also consider this when we're going on the flip side, right? And so, for example, if we know that the concentration of hydronium is 4.6 times 10 to the negative 3 molarity, all right, when we're looking at these numbers here, all right, so because this is strict concentration and not pH, all the digits here that we have is significant, all right? So in this case, we have 2 significant figures. Okay, and then if we were ever to try to figure out, okay, well, what is the pH of this concentration? Well, we know that the pH is equal to the negative log of the concentration of hydronium, all right? And so if we were to plug this number into this equation here, what we're going to have is pH equals negative log of 4.6 times 10 to the negative 3, all right? And what we get when we put this in the calculator, all right, we get that the answer is, and then if you try to figure out the right number of sig figs, so we see we have 2 sig figs here. Now, as we talked about with the pH, that first number, the number before the decimal, never really counts. So that means we need to have 2 decimal places after. And so the answer to this question would be, with the correct number of sig figs, is 2.34, all right? And so just to reiterate, this number here doesn't count as for sig figs wise, all right? But you want to look at the 2 numbers that comes after. So here, because we have 2 sig figs, we need 2 decimal places. And so that's why your answer is 2.34. So even though it looks like 2.34 is 3 significant figures, it's really, in the sense of pH and POH, it's really 2 significant figures.